Okay, so these are my solutions to the Chapter 2 quadratic functions test. I'm going to go through it quickly. Hope to get it done within about half an hour. It's currently Wednesday club time, and I've just uploaded the comments for your papers on ManageBack. So quadratic functions is something you have done since NY4, and it should have really been covered and covered again every year since NY4, but now we're doing it in slightly more depth. So the two new concepts really that we were thinking about were the discriminant and maybe some of the other properties like lines of symmetry, and especially finding the solutions to functions with a not equal to 1. So let's start with question 1. So question 1, the equation x squared plus 2px plus 3p plus 4 equals 0. Just note that this part here will be your constant. The 2p is your value for b, and in this case a is 1. But it's important to note that p is treated as a constant here, and therefore it's included in your c. So find the value of p, where p is a constant and has equal roots. So equal roots is the key part of the question. When I'm doing questions, I tend to highlight things or use some sort of underlining system, which helps me just read through them. So in this case, those are the two parts here that are important. So if it has equal roots, we know that b squared minus 4ac is equal to 0. So let's do that. We figured out that this here was b and that there was c, and a is 1 in this case. So therefore b squared would be 2p squared minus 4 times a, which is 1, times c, which is 3p plus 4, and that equals 0. So we can solve that for our value for p. 2p squared would be 4p squared minus 4 times 3p plus 4 equals 0. Distribute the bracket, 4p squared minus 12p plus 16 minus 16 equals 0. So since all of these terms are divisible by 4, we can divide through by 4 here. So we just get p squared minus 3p minus 4 equals 0. And then let's factorize that. So you can do some longer methods, but I think it's easiest just to think about now what goes into 4. So we've got 1 and 4, or 2 and 2, and then think about those two options. We've got to get to a 3, so 2 and 2 wouldn't work because 3 is odd, so therefore we need an odd number for our 4, so therefore 1 and 4 is the option, and now we've got to think about our signs. So to get to minus 3, we need probably minus 4 and plus 1, like that. So therefore p is minus 1 and 4. The one thing left to think about here is that p is a positive constant, and so therefore the solutions that we really want, or the solution we want here, is p equal to 4. For this value of p, solve the equation. So in part b, let's plug in our value for p. As I've said to you previously, if you want a really easy solution to these, and you want those 2 marks here, but you don't know what the value for p is, so let's say we don't know what question 4 is. An easy way to do this would simply to be, we get all the marks on part B if you just went, well, I don't know any of this, so I'll just let p equal 0, and then just plug in 0 into here. So if you plugged in 0, you'd have 2 times 0x plus 3p, but p is 0, plus 4 equals 0, and that plus x squared. And so therefore all you'd have left over is x squared plus 4 equals 0, and so you could say x equals plus or minus the square root of minus 4, which doesn't exist, of course, but that would still get you the 2 marks for this question. But let's do it properly. So using our value of p equal to 4, we can plug that into our equation, and let's do that in black. So x squared plus 2 times 4 is 8x. Actually, let's leave this with our working. 2 times 4, because it's 2p x, looking at this equation here, plus 3 times 4 plus 4 equals 0. So therefore we've got x squared plus 8x plus 3 times 4 is 12, plus 4 is 16, equals 0. What goes into 16? 2 and 8, 4 and 4. 4 and 4 is the obvious one here. So let's just plug in 4 and 4 equals 0, which means that we have a repeated root, and x is minus 4. So at this stage, when I've done a question, I usually read through it again and just double check that I've got everything right. So you can do it mentally in your head, or you can read it out loud, or you can try the problem again, or something like that. Just to double check you haven't got any mistakes, check all your lines of working. Once you're sure that they're right, the way I like to do this is I will double underline my answer. I'm going to rewrite p equals 4 here and double underline it because I'm sure it's right. And the same here, double underline it. That makes it really clear to the examiner what your answer is. And it also makes it clear to you when you're going back through a paper that you know that you've got this question right, so you don't need to panic about it. So you can spend your time elsewhere. It's just a quick trick. So here I did miswrite the question, or IB question bank did. So it should be f of x in brackets and then 2x squared minus 2x squared. Minus 1x plus 3. So obviously the key part to this question would be the f of x, and then it shows part of our graph here. Find the x coordinates of the x-intercepts. Okay, of the x-intercepts. Fine. So to find our x-intercepts, we need to find f of x. We need to let f of x equal to 0, so that we find these points where it crosses the axes, and it will cross the x-axis when y is 0, or f of x equals 0. So for part A, if we set the curve 2x squared minus x plus 3 equal to 0, we've just got to factorize this. There's a couple of methods for factorizing. I'll show you a more complex way if we don't know what we're doing here. So a method that I use for these ones, where you've got, for instance, a to and from, is I'll take down my value for c, 3, and I think about the factors for 3. So you could have 3 and 1, or 1 and 3, or 3 and 1. And then a quick trick here is that you simply multiply the first number by your, easier actually to multiply the second one by. And this is a version of the crisscross method, by minus 2. And then you take down this number as well, and you set these equal to minus 1. And then you see which solution works. This is something that I teach to my MY3s in more depth, but it's a good method for us as well. So we've written down our factors for 3, 1 and 3, and 3 and 1. And now we've got to think about which one gets us to minus 1. So minus 1, minus, there's nothing really there that we can do to get us to 1 there. Whereas in this question here, if I have minus 3, and then I use a double negative, then I would get a positive here, minus 3 plus 2, which does get us to minus 1. And so therefore, our factorized quadratic for this question would be minus 2x minus 3 and x minus 1 equals 0. And you can always double check that to see that it works by multiplying out the brackets. So now that we know our factorization, we can find what our intercepts are. So we have either x equals 1 or x is 3 over 2. So please note here, looking at that graph has 0 relation to the question, like nada, nothing. So don't be tricked by the graph to thinking one solution is positive and the other one's negative, because it's not always the case. In fact it is here. I have made a mistake. This should be minus 3 over 2. That's why it's worth double checking your answers. But in general, the graph is not always right. It's still a good lesson to learn. But we would get minus 3 over 2 here. Because if we set minus 2x minus 3 equal to 0, take the 3 to the other side, equals 3. And so therefore x equals minus 3 over 2. Good not to skip steps. So those are our two values for x, and those will be our intercept points. Now let's do our next section. Make some space. Our next section, they want us to find the coordinates of the vertex. One method here is to complete the square, like we got below. The other way, which I think is probably easier, is you take the midpoint of 1 and minus 3 over 2. We all right? Papers. Are you recycling? Don't mind me, I'm just recording solutions for the dy2s. So if that's our midpoint then, we want to find the coordinates. If we add both those together and divide by 2, we would find the x-coordinate for our midpoint. So 1 minus 3 over 2 will get us to minus 1 over 2 over 2, which is our minus 1 over 4. I think that is probably the easier method than completing the square in this case. So if we know that our x-coordinate is minus 1 over 4, let's find what our y-coordinate is. So f of minus 1 over 4 would be what our y is. And so in this case, it's minus 2 lots of minus 1 over 4 squared minus minus 1 over 4 plus 3. Minus 2 lots of 1 over 4 squared, which is 1 over 16, minus minus 1 over 4 is plus 1 over 4, plus 3. So therefore we get minus 1 over 8 plus 1 over 4 plus 3. Let's put them all over a common denominator. 1 over 8, 2 over 8, 3 times 8 is 24 over 8. And so what we'd really get here is 25 over 8. They're all gone, Lucas. They've been. Come and gone, mate.
Thank you.
No problem. So, 25 over 8. I think I'm right. Let's double check. Minus 2 lots of minus 1 over 4 squared is minus 2 lots of 1 over 16. Then plus 1 over 4, changing that would be 2 over 8. 3 times 8 is 24, 25. And so what we would get here would be this. I think I made an error somewhere. But this is why it's worth double checking you're working. Did I write in the equation wrong? Minus. Anyways, let's continue. So part B here, writing down the equation for f of x with our h and k. Well, if you know what our intercepts are, we know that f of x would simply be equal to minus 2 lots of x plus 1 over 4 minus or plus 25 over 8. The other method of doing this is we complete our square. So this is method A, and let's try method B. So if we were trying method B, we would try to complete the square with minus 2x squared, minus 2x squared, minus x plus 3. We can't simply divide through by 2 here because then we lose our solutions. We don't know that these are equal to 0 if we're finding our turning point, and so that's an easy mistake to make. So when we're completing the square here, we do want to take our 2 outside, but we don't want to divide through by our minus 2. So if we take our minus 2 outside the bracket, what we'd get inside would be x squared plus 1 over 2 x plus 3. And then completing the square here, for the inside of the bracket, we'd have minus 2 lots of x plus 1 over 4 squared minus 1 over 4 squared would be minus 1 over 16 plus 3. So therefore minus 2 lots multiplying out the brackets of x plus 1 over 4 squared plus 2 over 16, which is 1 over 8, plus 3. So minus 2 lots of x plus 1 over 4, 1 over 4 squared plus 25 over 3. So that looks like our solution. If we multiply out the brackets. So 25 over 3, since both of these agree, I can kind of be sure now that this is in fact the correct answer. So let's double underline those. Actually, it's good to write things out in neat. So let's write down our values for h and k in neat. So therefore we have h was minus 1 over 4, and k was our 25 over 8. And this here was method B. There was one other method that people used, and that there was looking at our turning points. And if we look at our turning point, and we know what the coordinates of our turning point are, which we did get earlier, and the coordinates of our turning point, well, what we were trying to find out, then we can also find our value for A and B using that method, or vice versa. If we know our value for A and B in this case, we can find our turning point using the formula for the turning point, which we worked out by completing the square, because literally it's B over 2A. And so if we know that B over 2A, there is our turning point, we can find out what that is. So moving on to the next question, question 3. Express f of x in the form of x plus p squared plus q. So on question A here, we've got to complete the square. So let's take half of our 4k, which is 2k, put that inside the brackets with our x and square it. Therefore we've got to take away minus 2k squared, because this is going to leave the byproduct when 2k is multiplied by 2k, which we don't want. And then we add our constant, which we do want on the outside of this, which is 3 plus 11k. So that there is our completed the square form. The only thing we have left to do here is to simplify it down. So we got, or multiply it out a little bit to get it into the form they want. Plus 2k squared minus 4k squared plus 3, let's go plus 11k plus 3, so that we recognize that this is a quadratic. And so therefore p would be minus 2 plus 2k, double underline, and q will be our minus 4k squared plus 11k plus 3, and we can also double underline that. So that gives us our two answers. Part B here, given that f of x equals 0 has no real roots. I've got to do my highlighting for this question, that's my f of x. No real roots, definitely highlight that. Find the possible set of values for k. So we know that b squared minus 4ac is less than 0 for no real roots. There is a quicker way of doing this, but we'll do this method first. B squared minus 4ac would be 4k squared minus 4 lots of a, which is 1, times c, which is 3 plus 11k. And we know that all of that is less than 0. So therefore it would be 16k squared minus 12 minus 44k is less than 0. Dividing through by 4, we would get 4k squared minus 11k minus 3 is less than 0. But we recognize this because it's the same as that. So the quicker method for doing this would have been simply to think about when you take this part here to the other side to solve your quadratic equation using your completed with square method. For instance, if it were equal to 0, we couldn't have the square root of a negative number, and so therefore that would imply that we'd have no real roots. So in this case here, we've done it using the b squared minus 4ac, which is absolutely fine as well. We could have skipped all of these steps by simply taking the value for q. But let's solve this now. We need this to be less than or equal to 0. Let's do the method that I was showing you earlier. Add page, and that there was for factorizing. Let's take down our 3. It doesn't matter if it's minus or positive, we'll get there later. And then add 1, 3, 3, 1, and then just do your 2 arrows crossing over. And so that's why it's called the crisscross method in a way. So we multiply this one by 4, and this one by 4, and we take down our minus 11. And then look at these and think about what signs we need to get to minus 11. So this gets us to minus 11, minus and plus. That means that we've got k plus 1 and 4k plus 1, and we have k minus 3. And so that's our factorization for this, and we know that that is less than 0. So therefore this gives us two solutions. Either k is less than 3, or k is less than minus 1 over 4. The mistake here that I've made, and this is what we talked about in the lesson, is that this inequality here makes no sense. So we're less than 3 and we're less than minus 1 over 4. So what I was talking to you about is that we want to find the critical values, is what it's called. And the critical values are for where this equals 0. And then we can look back at our question and we can decide about what our inequalities are. So what I'm changing here is I'm setting it equal to 0, because we don't know what our inequalities necessarily are from just factorizing this out. And this is called critical. You don't need to know it, but critical values, because they're the values critical to this inequality. Now let's think about a value in between these two. So if I pick 0, it's usually 0, k equals 0, and I plug it back into my inequality at the top, so 4 lots of 0 squared minus 4 times 1 times 3 plus 11 lots of 0. And let's see what that gives us. 4 times 0 would be 0 squared minus 4 times 1 times 3 minus 12, which is less than 0, tick. And so because we know that k is within our region, k equals 0 is within our region, we therefore know that our inequality in terms of k has to be k less than 3, k greater than minus 1 over 4. Part B completed. Part C, given that k is 1. Okay, k is 1, that makes sense, it's within our region. In fact, we didn't even need to do this in this case, because we know that k is 1 is right, because it's within our region, because they're telling us it in the question. Sketch the graph for f of x. So the equation when k equals 1 would be x squared plus 4x plus 4x plus 14. Yeah, 11 times 1 plus 14. So let's try to sketch a value for f of x for this function. First thing we know is it's going to be a smiley face because x squared is positive. Second thing we know is that it intersects at 14. So now we've got to decide whether the line goes through 2 points, whether it just touches the bottom of the curve, or whether it goes through none of them. And to decide that, we already have the answer in the question. No real roots. This bit here. And if it has no real roots, that means that the curve can't touch. The only thing we had to find out now, or discover now, is whether it's this side or that side of our line. And that's not necessarily as easy as it sounds, except that we've already completed our square. And so using our completed the square form, we can figure out what our turning point coordinates are. So our turning point coordinates would be minus 2k and something else. But we know that k, in this case, is 1. So the coordinates would be minus 2. And you don't even need to label that, they just want the intersection. But we know that it's going to be this side, because we know that this here will be minus 2. You don't even need to write it down. Question 4. Maximum mark 6. The diagram shows the function f of x equals ax squared plus bx plus c with the vertex minus 2 and 10. That's the problem with question bank, it doesn't come up with those. Key. 2 solutions for f of k. One of these solutions is x equals 2. Okay, let's find the other one. Using the lines of symmetry would be easiest here. And that's what they expect you to do. So if we've got 2, let's say that 2 is somewhere here. We need a value here such that the distance between that and the distance between this and this are exactly the same. So the distance from minus 2 to plus 2 is 4. So therefore the distance between minus 2 and this other point needs to be 4. So therefore we need minus 6. So therefore we get x equals minus 6. And I'm pretty sure of that, so I'm going to double underline it. Complete the table showing a tick for the parameters. So pause the video if you need any of this stuff that I'm rubbing out now. So complete the table showing a tick. For A, well, we know it's an unhappy face. Unhappy face. So therefore, because it's an unhappy face, we know that A has to be negative for 1. On the second part of this question,
Could we borrow a math book to
a what?
A math book.
Yeah, borrow a maths book. Make sure you bring it back though. Is it book 8? I've only got 2 copies of those now left.
It's book 10.
Oh, book 10. I don't have any book 10s, they've all been stolen. So it's fine. I didn't have any book 10s, do I? Oh, you want the 10E? I've got a couple of those. Okay. Make sure you bring them back. Okay. No problem. And then on part B here, for the value for B, we've got to figure out whether it's positive, 0, or negative. I think, for me, the easiest way of doing this is to think about what our vertex is. Because we know our vertex here, we know that our completed the square form for this would be x minus minus 2, x plus 2 squared. And then we would have a value for minus 10 here, plus 10. And we don't know what A is, but we don't need to know what A is. All we know is that A is negative. So if we were to multiply this out, imagine that we've got ax squared plus 4 x plus 4 plus 10. And then let's take this inside here. And let's go down to part B. We know that we're going to have an a for x, and that there is going to be our bx term. So comparing 4a and b, we know that a is negative, and so therefore b must be negative. Other ways of doing this could be what we were discussing earlier, which is our a over 2b, b over 2a, and we know that that there is the coordinate for our vertex, but b over 2a equals minus 2, and so therefore b minus b over 2a would be minus 2, and so therefore b would be 4a, but a is negative, which is exactly what we got by doing this method that I've done here as well. And so therefore we know that b is negative. Actually, I'll leave this on. Part C. State the values for which f of x is decreasing. So these are the 2 marks I didn't include on your test, and that's why I was out of 34. And that's because we haven't really covered it yet. We're going to do that in more depth once we do calculus. But the idea is that from minus 2 onwards, we are decreasing. And so therefore, we need x greater than minus 2. Yeah, I'm busy. No problem. Question 5, final question, and then we're done. I think this was one of the easiest questions on the test, and so this is really something I'm going to say about time management, is that we need to really work on our timings. So looking through questions and trying them, I understand it's a lot of words, so you don't want to read through it, but it would take you 30 seconds to read through a question, and out of 40 minutes, you can give 30 seconds away to read it properly. And then once you do read it, you realize that it's not very hard. And out of the 8 of you that completed the test, I think only 4 people got onto question 5. And those that did fairly well on it if they gave it enough time. So we know that the length of the pitch, the width is x, and the length of the pitch is 20 meters longer than the width. And we know that the perimeter will be 300, and we know that the area is greater than 4,800. So the length of the pitch is 20 meters, the width of the pitch more than its width. So this was just really a case of reading the question. So in question A, form a linear inequality in x. So that linear inequality here means that we haven't got an x squared term. So if we were calculating the area here, we would have an x squared term. So they want the perimeter used here. And also we don't know the area yet. So add up all those values there. We've got 4 lots of x plus 40. And that there is less than 300. You don't even need to simplify it. They don't say get it in the form or find the value for x. It's just write down the linear inequality, and that's an inequality. No need to find x yet. B, given that the area is greater than 4,800, so x times x plus 20, base times height, is greater than 4,800. Write down a quadratic inequality. Well, x squared plus 20x is a quadratic because we have an x squared term. And in fact, you probably would have to multiply it out simply to show that it's a quadratic, in this case, inequality. And so therefore, I think that a final answer should multiply that out. You don't need to take them all to one side, you don't need to solve it yet, that's part C. But you do have to write out your x squared term. So x squared plus 20x is greater than 4,000. So let's call this equation 1 and equation 2. So by solving quadratic inequalities, your inequalities, find the set of possible values for x. Let's start with 1, it's slightly easier. If we start with equation 1, we've got 4x plus 40 is less than 300, therefore 4x, you can do implying if you like, or just leave it as the next line of working, is less than 260, and so therefore x is less than 65. Let's use equation 2. X squared plus 20x minus 4,800 is greater than 0. So, trying to factorize this, I think it's easiest if we ignore our 20 and just leave it as 2, and we keep that as 48. Just makes it a lot easier. Because if we have x squared plus 2x minus 48, this would be much easier to solve. Because 48 is 6 times 8, and so therefore we get plus 8 minus 6. But in this case here we've got a whole lot of zeros, and to get the 2 zeros here and to make sure that we get the 20 on the other one, we need 2 zeros here. So if you're struggling on those sort of ones, just think about a simplified version of it and then think about what your zeros would be. And so in this case our factorization would be x minus 60, x plus 80 greater than 0. And so that leaves us with two equations. So again, this is why I like to keep things as critical values. We've got 60 and minus 80. Pick a value in between. Let's say x equals 0. So this is our critical values thing again. Pick x equals 0. Plug it into the equation above. We would get minus 4800, which is greater than 0. So therefore, that can't be the case. And so therefore, x equals 0 is wrong. And so this means that we've got a two-tailed inequality for x here. So our inequality would be x greater than 60 and x less than minus 80. But x less than minus 80, does that make any sense when we're thinking about the diameters of a square? Not really. And so therefore we really need this one here, x greater than 60. And so that makes sense. We plug 1 and 2 together. 1 and 2 imply that x will be greater than 60 and less than 65. So despite some distractions, we have done the test in about 40 minutes. And so in this case here, if we haven't got time to double check our answers, just make sure that you are spending a lot of time looking at your calculations when you're going through them. For instance, on question 2, A, I, and B, I would like to go over this again just simply because there's so much going on here for manipulation to find K, but I don't have time. So feel free to pause it at any point you want to pause it, and I will be uploading the PDF to your manage back